After understanding the formation of a peptide bond, we can discuss the formation of a protein. The first thing is that when we have the combination of many amino acids, we are creating a sequence of what we call the R substituents or the R groups or the residues of the side chain. If I have a polypeptide and I am not giving a number, we will have one R group for amino acid number 1, and then amino acid, the last is the one that has the free carboxylic acid group. Making just this as because the only thing that is changing is the side chain, we can say that this part is going to be called the backbone, and I'm going to highlight the backbone, which is alternating alpha carbon with peptide bond. So that will be the backbone. That is what repeats in the polymer. And we will have the side chains. That is the only part that we see differences that brings versatility to a protein, bringing some amino acid side chain being hydrophilic, some of them being hydrophobic. That can bring different opportunity for molecular interactions. So we have, in this case, just with the line to represent what was the backbone, because that is constant. That is constant, repeating the same alpha carbon peptide bond, alpha carbon peptide bond. And the only thing that we observe that is changing is the side chain of the 20 amino acids that we need to practice. So we have alanine, cysteine, lysine, and aspartate. So that part only is what brings versatility to a protein, that can bring what we discuss as levels of structures of a protein, and that has to do with the primary structure, the secondary structure, and the tertiary structure. If we introduce the primary structure, that has to do with the sequence of the R group. So for the primary structure, we say that is the sequence of the amino acids. We represented this with the letters, but the reality is that the backbone is not changing. The secondary structure, that will be how the carbonyl and the NH of the backbone are interacting, and that can bring us to two different levels of secondary structure. One that is called the alpha helix, and that is the creation of a coil in which a carbonyl is going to make hydrogen bond with the NH of 4 amino acids apart. And also the beta sheets, the beta pleated sheets is when you have the carbonyl is making hydrogen bond in any position with the NH of the backbone. But that has to do with any position during the polypeptide can make interaction of the carbonyl of the backbone with the NH of the backbone.